Good morning, Observe 2020. Thank you all for attending, regardless of which time zone you're in. I know that folks on the West Coast are probably waking up super early for this. So the keynote is The Road to Observability, Oh, the Trade-offs You'll Make, with apologies to Dr. Seuss. Congratulations, today is your day. You're off to observability. You're off and away. You have brains in your head. You have hands on keyboard. You can steer yourself any direction you go toward. But which direction should you go? Well, once upon a time, I worked at a company that duplicated a lot of work and didn't necessarily have the best observability into everything. There were 20 ways of doing anything because this was a giant company with tens of thousands of employees. And we had things that we professed that we wanted to do. Things like phonetically support our customers, for instance, if you believe that company is Rackspace, for instance. Or maybe it's focus on the user first and all else will follow, and really focusing on those user needs. But it turns out that's really challenging to do when you cannot see into your production systems, when you lack the observability that you need, or where you have many different competing systems all trying to deliver observability. So the road to happiness, we thought, was paved with tools, but actually it was the road to pain, not the road to happiness. Why? Because we set the wrong incentives for our engineers. We were promoting people for the wrong things and rewarding for the wrong things, and this resulted in a dysfunctional engineering culture. In particular, this company had a problem with not invented here, because nothing that you've already written could possibly solve my problem. I'm a snowflake. I have a scaling problem that's completely different than anything that's ever been done before. Invented elsewhere? Nope, not using it. Or even worse, people would do projects for the sake of getting their level 4 or level 5 or level 6 promotions. This was a project that was like overstaffed because people were just coming up with stuff that they wanted to do. And they had too much autonomy almost over building too many tools rather than simplifying. The opposite situation I've also seen in companies, where companies are told, like, you just have to trust the consultants. These are the tools that we use. Sorry, you can't use any other tools, even if they are grossly unfit for purpose. So there's a better way than having either too much flexibility and engineers running off building things that they shouldn't, or too little autonomy and people feeling constrained and hemmed in by their tools and lack of observability. So what's our goal as professionals who practice observability? What's our goal as people who deliver platform engineering or site reliability engineering? Well, we have two goals. First of all, we need to have appropriate reliability and scalability. And this is where I might lapse into a longer discussion of service level objectives, except I only have 40 minutes. So let it suffice to say that we need to make sure that our people are able to scale and that our people are able to get enough sleep and that they're not doing too much operations, and that our machines need to be able to scale with user demand. Look at Zoom the past couple of weeks. Look at Slack the past couple of weeks, right? Those services have had to scale up immensely without overloading their people and doing too much ops in a time when their people are already under stress. You need to make sure that your projects are actually providing the scalability benefits that you need, rather than just adding on complexity without benefit. All of this goes towards trying to maintain our service level objectives and service level indicators to make sure that we're delivering the quality of service that we need and also being able to deliver software on a predictable cadence. This means that we need to have appropriate observability. We need to have appropriate visibility into our systems to understand what's happening under the hood. Observability here is the control loop over our data that allows us to decide what we do with our systems and how we improve them. It's not the data itself. It's not logs, metrics, and traces themselves. Above all else, observability empowers us to debug novel cases in production, not in staging, not in dev necessarily, but in production, can we understand what's happening? And it's not just understanding what's happening in production when things are on fire. It's also being able to make proactive decisions to improve the resilience of our systems. It's about being able to understand what our code is doing and why, even when we're developing it and testing it for the first time. Making sure that we have appropriate observability into a release process so that we can understand what's happening and why is our code delayed, or when is our code going to ship to production. We need to have the insight into whether the features that we're building are actually shipping to end users and whether end users are actually using them. That user insight is incredibly important. And finally, we need to make sure that we understand where that dark hidden complexity is in our deep systems. We need to understand whether we're taming our technical debt or whether it's spiraling out of control. As I said earlier, observability is not just the instrumentation, and it's not just the data. It's this entire cycle between ergonomic instrumentation that we can easily add to our code, storing the data in an efficient format that doesn't break the bank, and having the capability to query it, to dive into that data and ask new questions about our data, rather than just the same canned set of known and knowns. We need to be able to explore our unknown and knowns. So throughout all of this, a lot of us get into platform engineering thinking, hey, SRE is a super in-demand field, right? It's super important. But it turns out that we deliver the most impact, not when we are the people who are blocking and waiting for people to come to us asking for help, but instead when we are proactively solving problems so that we disappear from the picture. We need to engineer for all teams, not just our own, and we need to make sure that we're meeting the needs of a diversity of teams. And we need to make sure that we're not just thinking about engineering narrow-mindedly as just writing software. Sure, we are software engineers, right? Software is in the title, but that doesn't mean that we write a ton of software, right? A building engineer doesn't build a bunch of girders, right? They think about which are the right girders to put into the structure. So let's think about this. We have a problem of over-engineering things in our organizations and rewarding people for doing the wrong things. How can we change this? How can we develop an observability practice that doesn't require having dozens or hundreds of engineers to work successfully? We need to change the incentives. So instead of saying, hey, look at this thing that I duct tape, isn't it amazing? Maybe don't do that, right? Instead, we need to be communicating, instead of about technology, we need to be communicating about success cases. What did people successfully do with our software? What was the problem that we were trying to solve? And how did we get there? What did we try? What were the dead ends that we encountered? And how did we ultimately wind up solving it? Is the solution that we came up with reusable by other people, or is it something that's bespoke, only usable by us? And how much work did we actually save? What's the net result? Are we saving engineers hundreds of hours in time, half an hour to an hour in every single incident they resolve? That's the result of our impact. Our impact is not the number of lines of code that we write. So we need to make sure that we're looking to make sure we can reuse as much as possible and looking left and right at other projects before we build from scratch. Do not glorify creating complexity on your teams. Do not promote people for writing code or writing complex software or writing design documents. Open source is definitely available, and it really should be the first port of call for us to think about, does something that's open source meet our needs, or is it something that we need to potentially build from scratch? Our coworkers' code also exists. There's this growing notion of something called inner sourcing, which is the idea of in a sufficiently large enterprise, you may be siloed from your coworkers, but you can dismantle those silos and access things that your coworkers have written. And that way you'll be able to reuse things and adapt things rather than reinventing the same thing 20 times over. Maybe if your Google size 3 times over is enough to account for all possible use cases. If you build 3 of the same thing, you probably have everything covered. You don't need to build it 20 times. And finally, vendors are definitely a potential solution to this because you are in the business of building software in order to serve a customer need. Is it a strategic advantage to your company to build a bespoke observability solution? If not, you shouldn't be building it, right? I work at an observability company, right? Like our entire mission is building observability solutions. It makes sense for us to build observability. And we have a dozen engineers dedicated full-time to this, right? We probably can do a better job at this than a team of 3 engineers or 6 engineers that's auxiliary to your company's actual business. So what should I do? Should I build? Should I buy? Should I go open source? Well, I can't tell you what to do. I really cannot. Your situation is unique, so I'm not going to give you prescriptive advice. Instead, I'm going to suggest some questions that I think you should think through. First of all, what is the problem that you're trying to solve? And actually, that's maybe not even the right starting point. The problem is not, I want more dashboards, or I want more pretty graphs to show my executive. I mean, okay, maybe if you're in a very dysfunctional organization where pleasing the executives is the only goal, but probably your customers have more important concerns than you wanting shiny graphs. So what is the problem that customers are having? And sometimes the customers are end users. Sometimes the customer is, if you're an engineering infrastructure team, your customers are other engineering teams, that's fine. And sometimes the customer is yourself. But either way, it's important to think about who is actually going to use this and to solve what problem. Metrics and traces are not the goal here. Metrics and traces are not actually the objective, right? They're a way that we accomplish having appropriate observability into our systems. So we want to keep our developers moving fast. That's our goal. And we have to repeatedly ask the question, why? Why, right? Like to really get at how we actually deliver value. Notice that I say why and not how here. I think how is important when we talk about retrospectives and postmortems in terms of being blameless, in terms of asking, how things evolved. But if you fixate on how in the sense of how are we going to build it, that constrains the solution space really, really quickly, right? Like we want to be broad in terms of understanding what's the problem space before we focus on how we're going to accomplish it. And then we need to think about who's actually going to run it, right? Who's actually going to keep this service up and running? And that might be, for instance, a reason not to pick open source because you might have to break both pieces and keep it and run it yourself later. And more importantly, who's going to maintain it? And I mean maintain not in the ops sense of running it, but instead in the code and product sense. Our observability tooling, our infrastructure, our platform tools, they are products. They deserve to have product management. They're not collections of random features, right? We need to maintain our code bases and cultivate them very, very carefully, or else we're going to have a bunch of garbage that's hard to understand. And we need to think about what options do we consider and publicize them so that other people can learn from our experience. Huge shout out here to Etsy. Etsy published a case study describing why they picked Google Cloud Platform over Amazon and Azure. I thought that was super impactful to see from peer companies to understand why did they go with the cloud provider they did. And it's okay to not have one silver bullet that's going to solve your problem, right? You don't need to say, because there's no one silver bullet, I'm going to design my own bespoke thing from scratch, right? Adapt an existing solution or two, right? You might need to extend one or both, but that way you'll wind up with something that is supported by other people rather than you going it alone. When you write new code, that's technical debt, right? Because you're going to have to support it until the end of time. Well, unless you upstream it. If you upstream code, then it becomes part of the shared commons that's maintained collectively. Do not fork Kubernetes. Do not fork Kubernetes. Do not fork Prometheus, right? Like use upstream code or else you're going to be saddled with a lot of technical debt. And as I said earlier, thinking about who's going to run it. Running software is technical debt. Software as a service empowers you to push that technical debt onto someone else who will do a much better job of managing it because it is their sole job to keep things up to date and develop that particular part of the software. If you're a startup, or if you work for a startup, you know this. But even if you work at a large company, this is true. If you build the wrong thing, it is ruinous. It wastes a lot of productivity. It wastes your engineers' morale when their thing doesn't ultimately wind up shipping or winds up being deprecated. And if you are a company that is under financial pressure, like high Series A startup, right? Like if you build the wrong thing and waste a quarter of development work, congratulations, your company now is 1 quarter shorter in its runway. So let's talk about how we can build a better observability tooling using the resources of our community. This is what I would like us to do as the observability community today. We need to listen first. We need to do our user studies. We need to really approach things from that product management perspective to understand what are the concrete problems that people are having and how can we improve their lives and their situations. We need to look at how people have solved similar problems in the past, as well as look at related fields. Gather requirements not just for our own use cases, but for related use cases, as long as we don't give into feature creep, right? Make things extensible without necessarily extending into that area and overextending yourself early. And maybe you'll find something that you can adapt. Look left and right. And write that code when you do, and document and provide examples. And this applies extra much if you are adopting an open source or vendor solution. Because when you adopt the thing the first time and have a working example, other people in your organization will copy it. You'll have 5 copies of foobar running at fast code that all come from the same source. So we need to make sure that that golden example is as good as possible and is kept up to date. And we need to really focus on upskilling each other, both within our companies and across companies. An active users community is a really big force multiplier. People should really feel empowered to improve and extend the tools that they work on, rather than treating them as black boxes or things that have had the security screws latched on so tight that you can't actually open it up and understand how it works and make it better. User confusion is really, really costly. If people are really confused and start working around your product rather than working with your product, or if you do something for your own convenience that results in saddling users with a lot of technical debt, that's going to really, really cost you and your users in the long term. But I also want to talk about a different form of confusion, a form of confusion that we had up until last year. With open census and open tracing in our communities, we had 2 different standards, and people really were not sure which one was going to last, which one should they adopt. And vendors had to write solutions that integrated with both of these rather than only targeting one backend. It was really, really frustrating, both as a user and as a vendor. So instead, we need to think about how can we share tools and code? How can we adopt the same idioms? How can we adopt things that enable people to use the same solutions? Make sure that people are learning about what people are doing in other organizations and that people feel comfortable adopting each other's code. And I think so far we've had a little bit of success with OpenTelemetry. Here's the list of roughly the top 15 major contributors to OpenTelemetry. You'll notice that it has a large number of vendors who otherwise would be very much at each other's throats, but instead we're all collaborating, and I think that says a lot. I think the other interesting thing to observe here is that there are customers on here, right? Customers like Zalando and Shopify, customers like Postmates and Zillow. These are all important clients to have. So it's got this nice ecosystem of vendors, of cloud providers, and of end users all working together in order to make sure that this project is a success. So users and providers both win when we have common things that we can target rather than going out on our own and developing many competing standards. So let's talk about how we can expand upon this success and really encourage and grow this community that we have. First of all, we need to use common idioms and APIs. This was a thing that was really holding back the observability community for many years, that there was no one standard way to do observability. But now things are changing. With the release of OpenTelemetry beta last week, we now have 5 languages that are officially supported with 2 more on the way, which means that you can use the same similar API across multiple different languages, all using the same shared terminology. You know, we have now one notion of what is a span, what is an annotation, what is an exemplar. So now people don't have to relearn concepts as they change language languages or instrument across many microservices. We need to make sure that we commit to maintaining what we build, that we're updating our example code, that we're updating our workshops, that we're helping people understand how they can use and benefit from things rather than have things get stale and rot. We need to make sure that people understand the context, that people can adopt OpenTelemetry both in large and small organizations and have examples of that succeeding both in small and large code bases. So people understand whether or not a given code sample, whether or not a given technique is going to work for their organization. A small startup, for instance, probably doesn't need the full OpenTelemetry collector or a even larger Kafka pipeline backing OpenTelemetry, right? So think about explaining who is this appropriate for so people can understand whether something's going to be useful for them. We need to make sure that people are upstreaming their code and specifications. And this is something that I think that we're doing a relatively good job of in terms of making sure that, for instance, as common patterns evolve in exporters for OpenTelemetry, that we're bringing them into the common APIs and SDK rather than having each person have to reinvent it themselves. We're finding maintainers across multiple organizations for code bases rather than have it all be maintained by the same company. For instance, the OpenTelemetry collector, yes, it originally came out of the Google Open Census effort and out of the Omnition efforts, but now there's many different contributors to it. Single company projects are really doomed to failure. And with much respect to the folks at Kafka and the folks writing Cassandra, right? Like those are projects that seemingly are dominated by one vendor. It doesn't have to be that way. We can have good governance and also a broad set of developers that really all contribute. But part of the cost of this is that we need to document our technical decisions as we grow. We need to make sure that people are writing good RFCs, are writing good OTEPs or OpenTelemetry extension proposals, right? Like enhancement proposals. We need to make sure that people understand why did we change this or why did we not do it. Overall, I want to say though that success with observability does not demand heroism. We need to make sure that we're each able to move on to a different job and still have everything keep on running. That even if one vendor goes under, right? Because this is a possibility in this economic climate, right? Like that our projects can continue. That people who have used a certain vendor's telemetry can migrate seamlessly onto another vendor without having to change their instrumentation. So what happens when we do observability well? As we do observability well, we wind up having our teams and our customers' teams be able to move much faster, being able to deploy multiple times per day, being able to fix issues in less than an hour, having less than 15% of their changes fail. These are all possible if you make the right improvements to your infrastructure. And yes, it's not just observability, but observability plays a large part. You'll notice that among the 20%, top 20% of teams, as measured by the Accelerate State of DevOps report in 2019, 57% of those top 20% teams were using observability techniques in order to enhance their ability to deploy to production. It's table stakes to do automated build and unit testing, but at the same time, you'll notice that there's still a large number of people stuck in that low to medium performer bracket. Let's reach our hand out to them as observability practitioners and help them level up so that they can become high and elite performers. Yes, maybe that it might involve helping them develop their CI/CD practices, but also they're going to need observability to understand whether things are working in production or not. So this is our story as Honeycomb. We're made up of a dozen engineers. People are aghast at this. They're like, I can't believe this. I thought Honeycomb was 100 engineers or 50 engineers. No, we're a dozen engineers. And our goal, right, like we start from the mission. Our mission is to make systems humane to run by ingesting telemetry from customers, enabling people to explore their data, and empowering end user engineers to make their software observable. So observability also has helped us as our superpower. It enables us to do things like deploy every single Friday. And not only deploy every single Friday, deploy 10 times every single Friday. This is a graph of every deploy we've done over the past year. And you'll notice that it has over 1,000 different deployments over that entire year. And we push code out every 10 minutes. Or sorry, it takes less than 10 minutes to write code and have it building. And then it takes us less than 3 hours for it to go out to production, including human review. We push builds every single hour, and it means that we need to be able to really quickly understand what's happening in production, and was it something that a user did, or was it a build? We develop a lot of confidence with testing and with observability. Having the ability to flip a misbehaving feature off or quarantine a user means that very few of our changes fail. Less than 1 in 1,000 changes catastrophically fail, which is about 2 to 3 per year. A flag flip takes less than 30 seconds to roll back a problem, and rolling back to a previous build takes less than 10 minutes. This really enables us to be high productivity, but it all starts with observability. It all starts with that ability to understand and get confidence in your code and fix your code when there's a problem. You too can have this kind of productivity in your engineering organization, or empower your customers to have that level of productivity. It just takes having the right building blocks and writing less software. So remember, instrumentation is just the start. You still need the right data platform. You still need the ability to query. But if you're starting to write instrumentation, I very much encourage you to write using OpenTelemetry. It's extensible, it's vendor neutral, and it's the way of the future. Overall, really, write less software, engineer more. Look around you, evaluate what's out there, collaborate with other people, and share what you learn so that all of the community can benefit. Thank you very much, and I'll be taking questions in the Slack channel.